In this video, we are going to see about the unit 3 utilization of electrical power. In the power sector, there are many factors: generation, transmission, distribution, and finally utilization. The power is generated in power station and the generated power is transmitted to substation. Again from the substation, it is distributed to the consumers and the consumers are utilizing the electrical power. So the end result is the utilization. Now in this unit, we are going to study about the utilization of electrical power. Here you see this power plant generating electricity. This is the generation part. And then here the transformer, that is, while transmitting the electrical power, we have to step up the voltage. So we need transformer. Why we are stepping up the voltage means for economical reasons. So stepping up the voltage, it is transmitted through transmission towers. You might have seen this in the outskirts of the city. And then again, in order to get the required voltage at the distribution side, at the consumer side, again it is stepped down. The voltage is stepped down using transformers, and now it is the distributed and is given to the consumers. The consumers are utilizing the electrical power. So the utilization is the end results of the generation, transmission and the distribution. Here in the consumer side, the electrical power is utilized as light energy or heat energy or the combination of these. So in the utilization part, in this unit, we are going to study about the illumination, how we are using it as a electrical energy. And then the second part is how heat is removed from a substance, that is in refrigeration case, and how heat is removed in room, that is air conditioning. We are going to see the electrical circuits for these. And finally, how the electrical energy is utilized in batteries. These are all the three cases we are going to see in this unit. In this video, we are going to see about the illumination. That is how we are going to use electrical power as a light energy. So first we see the important terms related to illumination. First, initially the light. So the light, it is the radiant energy in the form of waves, which produces the vision in the human eye. Next one is the luminous flux. We have studied about magnetic flux. Magnetic flux means magnetic lines of force. Here this is luminous flux. Luminous flux means how much light emitted by the source. Here the sun is taken as the source. How much light the sun emits around this. This is the luminous flux area. So we can write it in terms of energy in the form of light waves radiated per second from a luminous body. So this is a natural source of light, sun. The unit of this luminous flux is lumens. Next one is luminous intensity. Luminous intensity means how much light falls on a certain direction, on a particular direction. That is luminous intensity. In other words, you can say flux emitted by the source per unit solid angle. Here, this is artificial source of light. The flux emitted, this is while taking the surface. Here, this angle is the solid angle. So, flux emitted by source per unit solid angle. The unit is candelas. The next one is luminance. This illuminance. Here, two terms: illuminance, luminance. So, illuminance means how much flux it hit, how much light hit the object, it hits the object. So in a luminance means how much light is reflected back, that is luminance. Illuminance, how much light it hits the object. Luminance, it reflected back. So the luminance, you can write it as luminous intensity per unit projected area of the surface in the given direction. One more term, it is illumination. Illumination, the luminous flux received by a surface per unit area. In some area, how much flux is received. These are all the important terms in the illumination. Next we see about the laws of illumination. There are three laws of illumination. So the illumination E, the first law is it is directly proportional to luminous intensity. Illumination is represented by E and luminous intensity is I. So E is proportional to I. That is, luminous intensity means how much light falls in a certain direction. So E is proportional, directly proportional to I. Illumination is directly proportional to luminous intensity. The second one is the inverse square law. In inverse square law, the illumination E is inversely proportional to the square of the distance of the surface from the source. Let us take this as the source. Here light falls on the surface. Suppose if the surface is here, then the distance between the source and the surface is R1, means the illumination is inversely proportional to the square of this R1. So E is proportional to 1 by R1 square. Here general it is taken as R square. If the surface is A1, E is proportional to 1 by R1 square. If the surface is taken as A2, E is proportional to 1 by R2 square. That is the inverse square law. Inversely proportional and square part. And the third law of illumination is Lambert's cosine law. In Lambert's cosine law, the illumination E is directly proportional to the cosine of the angle made by the normal to the illuminated surface with the direction of the incident flux. That means here one surface is here, when source, that is light source, falls on the surface. Now here this part, this is the illuminated surface. The angle between these two, it is theta. So illumination is proportional, directly proportional to the cosine of the angle between the surface and the illuminated surface. So E is proportional to cos theta. Combine these three laws. First one is E is proportional to I. Second one is E is inversely proportional to R square. Third one is E is proportional to cos theta. So combine E is equal to I cos theta by R square. So this is the final equation of illumination in terms of luminous intensity theta and the distance r. Next we see the artificial sources of light. Here there are three types of artificial sources. First one, due to the temperature incandescence. That means the example is incandescent tungsten filament lamp. Here one filament is present. When electric current passes through this filament, this lamp is filled with inert gas. So here this tungsten filament. So when electric current passes through this filament, it illuminates. So this is by temperature incandescence. And the second one is the carbon arc lamp. Example is carbon arc lamp. Here the arc is established between two carbon electrodes. Here one electrode, here in this place another electrode. Two electrodes are present. Two carbon electrodes are present. In between two carbon electrodes, an arc is produced. When electric current is passed through this, an arc is produced. The final one is discharge lamps. In the discharge lamps, here the examples are sodium vapor lamp and the mercury vapor lamp, and finally fluorescent lamp. In this unit we are going to see sodium vapor, mercury vapor and fluorescent lamp in detail. So discharge lamp, what is discharge lamp means? When electric current is passed through the gas or vapor, this lamp is filled with gas, any gas or vapor, which renders it luminous. So electric current is passed through gas or vapor, which makes it the lamp luminous. So this is the discharge lamps. Here there are two types of discharge lamps. First type 1 and type 2. In the type 1, the color of the light is the same as produced by the discharge through the gas or vapor. So example, sodium vapor lamp. The same color produced by the discharge will be the output. So sodium vapor lamp and mercury vapor lamp are the examples of type 1. In the type 2, it uses the phenomenon of fluorescence. Here the discharge through the vapor produces ultraviolet waves which cause fluorescence. So this is example is fluorescent mercury vapor tube. In the next video, we will see about the sodium vapor lamp, mercury vapor lamp and the fluorescent tube. Thank you.